Welcome to Doozer Shop. I'm going to take you on a journey here. I'm going to set up my International Harvester inline 6-cylinder engine. In this case it's a 264. They also made a 220 and a 240, but this is a 264. And in the gasket kit they included not only a rope type rear main seal, but they included a lip seal, a press-in round conventional like lip seal like you've been probably familiar with. And I'm going to set it up to bore out the features that house the rope seal, and I think it's a good idea to use the one piece rear main lip seal, because I got it in the gasket kit. And I've seen this done on the internet. The internet. And I got a horizontal boring mill. So let's take a handheld and show you my setup and show you what I'm thinking and how this might work. Let's go handheld. So to recap, let's see here. So that's, put some light on the subject. That's the rear main bearing cap, and half is in the block, of course. And you can see when I zoom in, it's all brown, black colored because of the grease oil. But that's the rope seal, and it continues around. You can kind of see it. There, you can see the contrast a bit better. Maybe, if it doesn't focus out. And I know in '86 Chevy finally went to a one-piece lip seal. This almost looks like silicone. But, you know, that's got to be 4 inches. National. But the deal is, let me kind of, I would be boring out, I guess, to that back, leave the back lip, take the front lip, and you know, that would press in as it were. So I'm going to have to install this in the block and get the block on the boring mill. So I had the engine on the stand forever and a day, and I was oiling the casters. There's the head. Tilted valve. Guys call them straight valve or tilt valve, but they are tilted valves. Now, I've got this idea. I think his name is Jason McConville, and I think he's in Vancouver, BC. I'm not sure exactly where, but he's got the same Giddings and Lewis boring mill, and he does this on his engines he works on. The guy's pretty cool. He does. He buys 302s, 351 Fords and small block Chevys, and he rebuilds them. He buys them off the internet or Craigslist or whatever, and he rebuilds them because he's got all the fixturing with a beautiful Giddings and Lewis like I have. Pretty cool guy, but he's the one that gave me the idea. Now I'm setting this up. I got the block on the table, and my infrastructure, it's only a 4-inch hoist beam. It's probably only good for, you know, 500, 600, 700 pounds. But it services the lathe, excuse me, for the chucks. For the chucks, because they're heavy. And then recently, yesterday, I made, this is a 20-inch boring head, and I made a skateboard. I had a piece of, what is that, 8-inch channel, I'm going to guess. And I tack welded some wheels onto it. And I thought, you know what, I'll drill and tap 16 holes, or I can just put some 1-inch tack welds on there, and I just welded them. Because they're not great wheels, they're all full of metal chips, and I put some rubber hose. But it serves to move around the darn blang heavy boring mill, facing chuck, whatever you call it. All right, now guys like Brian Block in Kentucky, Brian uses his mill like this all the time. So for him, a video like this is like an everyday thing. But for me, I don't do this kind of heavy boring that often. So I got it up on the table. And I mean, I had to do everything. You know, you saw me with the videos with the drawbar for the tooling and all that. So I had to figure that out. I didn't have any, I had one 5/8 T-slot nut, T-nuts, and one. And I found a pack of 5 on eBay for 20 bucks, and it's like, you know what, for the time it takes to make them, I'm just gonna buy for 20 bucks and free shipping. So now I got that, and this, it's funny, this all thread, it's 5/8 B7 all thread. It's the same all thread I used, see that's the attachment point for the beam. It's the same all thread I got coming off the ridge beam up in the attic. And these are the leftover pieces. So, and I just got them down in the bores, you know, with a T-nut. And I don't know, I had some unistrut that I'm using as a clamp bar. And, you know, I think this will work. So anyways, I'm going to get busy here. I'm going to make this a edited video where I start and stop and whatever, and piece together because I'm going to have a lot of takes. So I used a carpenter square to get this initially squared, to get it close, so I'm not indicating all day. I got to indicate the transmission, where the transmission bolts on the bell housing adapter, and this is kind of cool. This is a bolt-on adapter like a Cummins, if you're familiar. You can kind of see the bolts on and dowel pins in there. It's like a Cummins. At least for the 4 speeds and the 5 speeds. The 3 speeds had a different clutch housing, which is a little strange, but I'm probably going to do the 4 speed with this one. So let me get going, and we'll show you as I progress with this. Alright guys, well, before I turned loose on the engine for doing the boring of the seal, I decided I just want to set up real quick and do a test bore to make sure everything's jiving and I'm not boring a taper or nothing's weird or anything. So I got the boring head clamped in the spindle with my new clamping system with the 1/4-inch bolt and draw key and all that happy stuff. And I got a little carbide insert bar, and I just strap clamped down just an aluminum block I had, and just taking some trial cuts, and I'm going to take some bigger cuts in a minute, and do a measurement and make sure it's round and not tapered and everything. So that's the plan before I actually, you know, go in and bore where the seal has to go, you know. So I took a little cut. It seems to be working fine, but I want to take a decent sized cut and make sure there's no chatter from something being loose or weird. But anyhow, yeah, that's what I'm going to do, and I'll bring you back and show you more. Alright, we got this test piece set up here. I'm going to crank in, let's see, 20 thousandths on the diameter, me get it in gear here. Alright. Let me hit the power feed. It's going. It's cutting. Get some lube on there. Shot a little transmission fluid on there. It's a really pointy insert. The nose radius is very minimal, so it's a sharp cutting edge. So I'm using very fine feed because I have very little nose radius. But it's feeding. And I just want to make sure it's boring a straight hole. I don't want to shank out on my cutter boring bar. Because it's a thick bar, not a lot of stick out. You stop it there. Let me retract it. And I'm feeling the cut pressure. Not a lot of cut pressure, which is good. The tip looks good. All right, just a wee bit of built-up edge. That's why I threw the oil on there. These are uncoated inserts and they like to... Now, that's a very smooth finish. It jumped when I first applied the power feed, which was my fault, and I'm learning how this works. Let me cut that ridge off. Find neutral, stick it in gear, put it forward. We'll just roll it in manually and cut that out. What I can do, I can turn off. I know you don't know what I'm doing. Turn off the power feed, hand feed. Do I like hand feed? Let me back it out. Alright, well that's fun. All right, let me look at that and see what we got here. right, that seemed like a success. You can see the insert I'm using. 1/4" inscribed circle, triangular carbide. It's actually a Cermet insert, but the nose radius is super sharp. Finish looks good. It seems to be parallel, nice and straight. This thing, it cuts like a dream. Yeah, I didn't want to cut too deep. When I said shank out, I mean, you know, it's a 3/4" bar in a 1" head, because it's got a bushing right there. But it's only got to stick out of a little bit before it goes to the full 3/4 there. But that's going to be just fine and nice and rigid for poking into there and doing what I got to do. So now that that's a success, I'm going to break this. Well, I don't have to break it down, but I'm going to square up the block. I'm going to indicate it and tighten the hold down clamps because I just got them in there kind of loose. I'm going to indicator with an extension rod and indicate that bell housing flange. I think is the best. It's a good way to do it. I'm not going to say it's the best way to do it. And don't forget about droop and sag and all that stuff. But this came out really successfully, and I kind of knew it would, but you don't know if you know. You got to check, right? And I could have just gone for the gusto and bored the block directly, but I got to see. All right, let's indicate the block in. All right, guys, I'm still working on it, but I took the bell housing adapter off. I've been going around. I can show you with a plunger style dial indicator, a mini guy, in this arm. And it may have a lot of flex and droop. I didn't think it had a lot, but I was getting good side to side on the, I'll show you the rear flywheel, no, not flywheel, bell housing adapter. So this is it on the floor. And the face down to the floor is the transmission. And this shape bolts to the back of that block. Now, like I said, a Cummins B series, I think, is a very similar way that they do this, because you can interchange the rear bell housing adapter on a Cummins. And I mean, I'm not saying it's the same pattern or nothing like that. I'm saying it has this concept of a you know, a removable flywheel housing adapter. So this is the top, the starter. I'll just turn around because magic of video. The starter bolts to the top. So this is the top of the engine, this is the bottom. So the bottom, this lip was coming out like 10 thousandths. And it could be worn, or not worn, but the way the engine's in there, it's supported by, how is it supported? I gotta check that. I think the 3-speed that's in it now, it's got motor mounts on either side of the transmission bell housing. And the front of the engine where the harmonic balancer is also. So I got a rubber mount. So this would be prying this apart at the bottom. I don't know if this was warped or not. I'm going to clean all the surfaces really well
set it on my surface plate and check for gaps or rock or whatever. But that's the reason. It's the reason I decided to, you know, take off the transmission adapter, and I'm going to indicate right off the block. And like I said, it's it was good side to side, and that's what I was trying to achieve, is, you know, lateral alignment of the block. I didn't even get to the spindle bore center line yet. Nope, not yet. So I want to put the indicator in maybe with a shorter bit of linkage and indicate right off the block. And I'm scraping it down. My palette knife broke. It used to be another 2 inches or so longer, and it broke off shorter, and I re-sharpened it on the belt sander. So I got a stubby now, and I really like it. These are called artists' palette knives. You can get them at the paint store, like the craft store for painters. Not like wall paint, but artist paint. So I've been doing that. Scraping this off. I'm going to scrape it some more, wipe it off with lacquer thinner. And gee, I didn't know indicating something could be this much of a pain in the butt. Anyhow, thought I'd show you that. Let's get scraping, and I'll update you again in a few minutes. Alright guys, let me show you what I got. I ditched the Noga Flex arm, and what I got here, it's a piece of 1-inch mechanical tubing that fits in the 1-inch boring head, and I got a 1-inch locking shaft collar, which is secured by a 5/16 18 socket head Allen bolt, Allen screw. Because it's 5/16 of an inch, I got an indicator swivel that goes from 5/16 shank to 1/4 inch shank, and I've got a Testa indicator. I call it Testa. But anyways, this has a swivel gimbal back adapter, and it's a 1/4 inch shank. So that's the indicator snug. And so I'm rocking out here on the back face of the block, and you know, numbers are arbitrary, so my dial's right on 15. I can swipe it, you know, from this side to this side, you know, and it falls off in that square area, but, you know, down the bottom, I can swipe the whole thing and pretty much get that same number all the way around. So this thing is good and square. I've been using my my Cook lead hammer. I think it's Babbitt, but that works really well for tapping stuff around. And I snugged in my bolts with my crescent wrench, so the hold downs are tight. And I need to indicate next the bearing, the center line of the crank bore. But I really like using this rigid setup I came up with, and it's you know, just junk out of the drawer, right? I had this is pipe and tubing for the most part. Yeah, these are pipes and tubes, and you know, I got above it, I got solids, right? Is it? Yeah. Solid shafting. And this stuff's pretty handy. You know, my cabinet of goodies. I don't know what I was doing in there. Oh, that's where the collar was. Well, let me get indicating the crank center line, and I got to put the piece in. And this is considered, you know, a deep skirt block. I think the Ford guys call it a Y block. Where normally on modern engines, well, I shouldn't say that. When they went to the lightweight castings in the early 70s, late 60s, probably mid 60s, let's say mid to late 60s, the oil pan rail, instead of that oil pan rail being where it is, they changed it to the center line of the bearings, and the caps, you know, stuck down below into the oil pan. So this is a deep skirt block. So the skirt would be, you know, anything from the crank center line up is a skirt, right? It's got a rib there. So the insert piece, you can see this half circle, that's for the, that's a different rope seal. It's not the rope seal, it's a rope gasket, I guess you'd call it. So they pack rope in there, and then the gasket kit they give you. Rubber sticks of round sticks, cylinders of rubber. But anyways, the bearing cap, I had to pull it out with a puller. It was fairly tight. So it's an interference fit. It is a line to line or just a little press fit to get it in between the uprights here. So I'm going to stone all this out, scrape it out, clean it out, stone it, wash it, you know, with lacquer thin on a rag, and see if I can get the piece fit in there. It's almost like, I want to say the gap, right? It's like a gap bed for a lathe. Anyhow, so let me indicate this where the bearing goes, the journal where the bearing goes in the block, and center my you know, the head up and down in the table. So it'd be the table side to side, right, to center that, and then the whole head moves up and down. So I'm going to indicate that next, and then I'll, I guess, fit the rear bearing saddle. So back in a minute. All right, guys, still working on it. I got a shorter piece of pipe, and my collar is right up against the boring head. And my linkage, you know, I'm tight there, but I'm not too tight. So I'm right on, focus, the arbitrary number 5, and I can maintain that 5, you know, sweeping from this side to the bottom to this side. And I don't think I've got hardly any indicator sag. I might have a small amount, but I don't think so. Because the only real sag would be, you know, that shaft there and the weight right from the swivel joint. I got a car mirror. When I hit a tree with my car, I saved the mirror, passenger side mirror. I mean, it was driver's side, doesn't matter. So I could, you know, read the indicator when it's over on this side. So, and I figured out, I says, where's the axis lock for my table? And I had no idea that those Allen screws, 5/8 Allen screws, was the gib lock. Because the gib is right, you know, I can tell the gib's over, well, it's over there. And I says, I bet you they bear on the gib. And I pulled the screw out, and it was really flat on the bottom, not like a rolled thread baloney. And I looked in the holes, and it looked to be some brass plugs in the holes. And I said, okay, those are the locks. And I happen to have a 9/16 Allen wrench. Lucky me, because I got a whole box of Allen wrenches. And what I did is I unscrewed the bolts, the cap screws, and I pumped a whole bunch of, you know, I got that full of transmission fluid, and I just pumped transmission fluid in the hole where the threads were, and really quickly I screwed the nut in, and I hydraulicked some transmission fluid in there, and just brown poopy looking water came out. I did that on both of them. So I want that gib to be lubricated. Everything works on the lubrication system on this thing. There's actually a Doozer pump. You can't hardly see it, but you reach your hand in there and you give it a couple squirts. And the lead screw receives oil. The table ways get oil, and it starts dripping oil out. The red transmission fluid I use, because I want to use the red as an indicator of, if the oil's flowing or not, and a detergent to clean everything. But now that I'm indicated in, I've locked the table. That black handle, I locked the up and down elevation, and that changed the side to side like 2000. So when you lock that, make sure you check your table, because when I locked that, I had to redo the table. And that's the lock for the bar. That's in and out. That doesn't matter. So I'm locked on 2 axes, and I guess the question is, do I bore with the spindle or do I bore by sliding the table? And I think I can bore with the spindle. It's probably more rigid to lock the spindle. I don't know. I have to think about that. But what? Is it only for drilling holes, or can we bore with it? I think it's going to be fine. Probably, yeah, it'll be fine. All right, let me work on putting the bearing cap in there, and let's continue on. All right, guys, I wanted to show you, had a whole bunch of stuff going on here, mainly cleaning the area where I'm going to install the rear main bearing cap. As I talked about a minute ago, this is a Y block, or a skirted block. And I got my little stone here. I cut one of my flat stones in half. So I got 2 of these. And this mineral spirit's in the tray. And I'm cleaning everything out and stoning it flat to get the burrs out. And it looks like this side was scraped. Look at those little scallop marks. I'm trying to hold the camera still. So there are radial lines from a mill cutter. You can see there's arcs in there. I guess more arcs than, they're not radial, they're arcs. The arc lines from like a mill cutter that made this cutout in the block. But I gotta think that those are scraping marks, that somebody fine-tuned the fit of this feature on the block. That's that side. Let me go around the boring mill to the other side, and I'll show you the opposite side of the block. I find it interesting, there's the other side, and well, let's see if I can zoomy in. This side is a little more coarse. When I stoned it, you can see the reflection off my finger. There's a high spot there, right? And if you go up, this whole edge was high. You can see how it's polished, shiny. This whole edge was high. I could just feel it with the stone, because the stones are very flat, and I just concentrated my effort, where it's touching. The highs will cut. But boy, look at that. That sure looks like, God, it almost looks like someone went at it with a scraper and a file. Look at those fingerprint striations. That could have come from a file. Or a scraper that, was in need of sharpening. But like I said, this side's pretty rough. The other side I just showed you a second ago is bit more refined. But I think somebody came in here with a power scraper, and in a production line, you would think that that would probably be the case. But anyhow, I wanted to show you that because I thought it was interesting. And I'm going to continue to clean this block. I mean, it's almost done. I stoned the parting line and everything. And I'm going to clean up the bearing cap that goes in here. And I'll show you more in a few minutes. Okay. Fun and awesome. So let me explain what I'm doing here. This is the bearing cap, and I just spent more than a half hour cleaning it, stoning it in the parts tank, filing it, deburring it. Stuff takes so freaking long. Anyhow, all right. So this is the bottom, and these are the sides that fit up against the skirts of the block. Now what I'm doing here is kind of maybe confusing, but the block is relieved back where that scraping was. I don't know why it was scraped, but because it's clearance. It's clearance between the block skirts and the bearing cap here up until the last 1/4 inch of the bottom. And that 1/4 inch at the bottom steps in, and I measured the distance across the truncated in steps in the block where it registers at the bottom, and I measured across here. The block measured 5.122, and this bearing cap across measures 5.129. So that's 7 thousandths press fit, interference fit. So this thing is a 7 thousandths interference fit in the block. And dude, let me tell you, I had a heck of a time getting this sucker out. That hole is, I think it's 5/16. Okay, that's what I used as a puller hole. There's nothing else that goes in there. So I had a 5/16 bolt, and I had, a piece of all threaded rod, and I had a strong back. I think I just used a milling machine clamp, and I packed it off the block to give me a distance to pull. And I used the threaded rod, the all thread, to jack this out of the block. And once it came out a 1/4 inch, it was pretty easy. It wasn't totally easy because there's still a rope seal in there, a rope gasket, I guess you'd call it. But I made the executive engineering decision that 7 thousandths press fit on a 5-inch opening was too much. So what I did is, as you can see here on the Boyer-Schultz surface grinder, I took 2 thou off each side. Now, right, wrong, or indifferent, and how dare you question the factory international harvester engine engineers? Well, you know what? I am, okay? Because there's no freaking need to have this in there with a 7 thou press fit. So by taking 2 off and 2 off, that's 4, 5, 6, 7, 3 thousandths press fit is what I am left with. 3 thousandths press fit on a 5-inch opening. Dude, it's gonna be more than fine. And it's got 4 freaking 1/2-inch bolts holding it to the block, right? And it's only like 130, 40 horsepower, something like that. It's gonna be fine. And I did this because I got to fit this in, bore the seal, pop it out, and dude, all my bit of engineering brain tells me 7 thousandths was just ridiculous. So I go, ooh, I'm kicking stuff. I've ground up from the bottom approximately 1/5 of the wheel, which is 1/2 inch, and that feature that sticks out in the bottom of where this fits in the block comes up only 1/4 inch. So I'm plenty of clearance higher than, you know, it goes, that feature. So I'm gonna put it in there and see how it fits. Right or wrong, did I screw this thing up? I doubt it. But I say 7 thousandths too much. Leave me a comment if you agree or disagree with me. But yes, I'm absolutely questioning the factory on this one. So, see you in a bit. Alright guys, I put that rear bearing cap in the block and I drove it in with the lead hammer, Babbitt hammer, lead hammer. Dude, it went in beautifully. It went in with a couple light taps. I think I got, you know, 2.5 thousandths of interference fit. It's not going anywhere. I don't think I ruined this thing at all. I'm much happier than beating it in like a crazy person. So I'm gonna get the bolts in there and you can feel the parting line. You can't see really, but I'm feeling the parting line where the bearing comes together on the surface, and that's money. That's equal, and this side is equal. So I'll get the bolts in there, I'll get it torqued down. I think the spec is 50 foot-pounds or something. I don't remember. It's not that critical because, you know, I'm taking it apart again. But then I set up the boring bar and go for broke, as they say. All right, bring you back. All right, guys, got you back. Got the cap installed. I got the bolts in there. Those are place bolts. Really cool bit of engineering. If you don't know what place bolts are, Google that. Torqued them to 40 foot-pounds. Lubricated them with petroleum jelly. This stuff has got a lot of lubricating properties. It's pure petroleum. It's like a really thick oil. It's not grease, which is like a soap thickener vehicle with oil in suspension. Good stuff. Used a lot in drawing, metal drawing and dies, deep draws. So I use Vaseline for a lot of assembly here in the shop. Like I said, torqued them to 40 foot-pounds. That's just a guess. Took the boring head out, switched to the drill chuck, and I got a different indicator here just to triple check everything. I don't know if you can see that. Federal Test Master, whatever. And I'm swiping where the bearing would install, or the shell insert bearings would install. I'm getting 0 all the way around. This thing is shifted about, just a little under 1 thousandth, which I don't care. So I'm getting 0 there, 0 at the bottom. I'm getting 0 just before the parting line on this side, and it jumps a little from one to the other, but maybe a couple tenths, maybe a thou, not even a thou. But anyways, so 0, 0, 0. I mean, it wavers 1/2 thousandth in the corners, but that's just what it is. If I indicate the actual shell where the rope seal would go, the outer shell, from this side to that side, or that side to this side, whatever you want to say, I get, if I zero it on that side, I get 12 thousandths different here. So that bore for the seal, apparently is 12 thousandths out of coaxiality, out of concentricity with the bearing shell. And man, I'm telling you, here, let's see if I can roll this. I don't know if it will focus. It'll probably say no, screw you people. So that's 0. This is just a kiss. It was a kiss above 0 before. You can see in the shadow. And the eclipse of the light. And I'm right there at 0 again. So I'm just maintaining either 0 or just a tick above 0. Everywhere I go, okay? And just for a reality check, I indicated this surface from here all the way around. I don't know why that yellow inspection mark is there. All the way around to there. I indicate axially to make sure that the block is still square and nothing moved when I torqued the bolts in, and it is freaking 0 all the way around this face, indicating, you know, axially along the axis of my setup here. And radially, it's 0, you know, all the way around the block part. And it's 0 up top and 0 at the bottom. Wavers a little bit because, like I said, the cap is installed, whatever. I think I'm good. The fact that the seal, where the seal goes, is 12 thousandths out of concentricity with the bore of the mains, I think is just a manufacturing how they did it, man. I mean, I think that's, you know, I think I'm putting it back better, reestablishing, you know, the seal to where the bearings go in the crank center line than it was with the rope seal factory original anyways. So I guess I'm going with this. Anxiety and whatever, and fortune favors the brave, right? I'm brave enough to cut this block, and hopefully I'll get some fortunately less leaky seals. Favors the brave. I don't know who said it, but I kind of like it. All right, let's go on to the next step. All right, guys, measuring my oil seal. I'm getting 4 inches, 5, 6, 7, right? So 0.5625, call it 0.563. 0.563 is 9/16. So 3. So 563. So 4, 5, 6, 7. So 1, 2, 3, 4. If I make it 4.563, which is 9/16, 4 and 9/16, 4, 5, 6, 7, 1, 2, 3, 4. I got 4 thousandths press fit on a 5-inch seal. So that's what I'm going with. I'm going with 9/16. I'll probably err on the little bit more, right? On the 2, 4.562 and a half. So call it 4.562. So I'm going to zero this caliper at 4 and 9/16 and try to bore it to size like that. And like I said, that'll have a 4 or 4.5 or 5 thou press fit on the seal, which is nothing because it's a steel ring. It crushes easily. And I measured the thickness. It's exactly 3/8, 0.375. So that's what I'll do. And I think what I'll do is I will lock the coil, put a mag base dial indicator on the bed, and move the table towards, you know, my boring head, my tool once I zero it out. And that's how I can control the depth. And I know I bored that little block by using the coil feed but I can't control the depth with the quill. I just don't, I don't know how to control the depth with the quill. And I watched that video that Jason, I think his name is McConville, did again, and Whiplash Machine is his YouTube channel. So I went and found on Whiplash Machine his video of boring the seal on a 302 Ford or a Chev or something, and he had a bed mounted indicator, and that's how he controlled the depth. So I guess I'm going to take advice from him and do the same. And let's get set up. All right, here we go. We're going to try this. You guys ready? You watching? All right, let's crank her up. All right, let's see here. Table feed figured out. We're going to take a light pass in 375. 0. Under. 150. In the middle there. 200. 250. 300. Let me do some hand feed. 300. 240. 350. 360. 375. Where does that leave us? Oh, we're just barely not touching that inner. We're just shy of it. Okay. Well, that works. So let me back us out. And I never really measured where we need to go. So let's get a almost a ½ inch. So if I didn't know it was that much. It was not. Okay. So approximately a ½ inch is what I gotta take. Alright, let's advance the boring head. 20, 30. There's 30. Let's see how 30 cuts. Alright. Alright. put a piece of felt down, contains some of the dust. Right, so that was 30 thousandths. Did I lose my Allen wrench? No. 1, 2, 3. 30 again. Let's see what this does. Alright. Creep up the table. Just do power feed, man. Go. At 30, I'm afraid to do 50. And 20, 30. I mean, I don't want to do 50. I'm afraid of it. Do it again. Go. Cut. Take it back, cut some more, 10, 20, 30. Put the clutch in. Tricky to run this machine. I should have brought the table up, but no matter. We'll power feed it. Kick it in neutral, turn off the this in neutral. It's pretty boring. I'm probably gonna pause it and do some more. Slowed her down a bit. Final pass, I think. Pushing my dial. Pushing on the table. Ever so slowly. Alright, I'm gonna pay attention here. I gotta stop this thing in a bit. Bring it back. Alright guys, we're to size. I'm super happy with the measurement. It's right on what I wanted. I'm going to have to chamfer the edge to make, you know, make a lead-in chamfer. I am really happy right now. Just so happy. That's working out so well. I'm happy I got all these boring bars that I'm able to use to do all this cool stuff with. Tighten that, loosen that, and it's a different size. I hate when they do that. This table, boy, it moves surprisingly nice, you know. Don't drop it, Doozer. I should get my T-handle wrenches out. That would have been the hot ticket for this, right? That's what we want. Yep. Let's spin a rooski and see what happens. Engage. Come on, Bubby. Alright. Just hand feed her. Give it the chamfer. Lead in. Stick out. Little chatter-ratter it wants to do. I'd say that's perfect. You don't want to go too much. Hell yeah. Alright. Get you in close, shake you all around. I hope you can see that. but perfect. Perfect, perfect, perfect. All right. So, get the Sealerooski. Oh. Get your hand out of the way, Doozer. Oh man, it wants to jump right in there. Oh, that's sweet. Dude, that is sweet. Well, thanks for sticking with me on all this. I got a bunch of stuff to vacuum up and tools to put away. Yeah. But all the preparation and making those the keys to fit, you know, the boring shanks and everything. You know, I need every machine to be tooled up and running. So, man, super excited. And you know, learning the machine and learning, you know, what moves when you tighten the locks and how to, you know, just get everything set and zeroed out and trammed X, Y, and everything else. It's just, it's a lot. It really is a lot. But there you are. And like I said, thanks to Whiplash Machine, Jason, for making his video. He's got the same Giddings and Lewis. I'm just so thrilled right now that this is actually, you know, I mean, guys like Brian Block, they do this every single, well, a lot. I don't know if he does it every day, but you know, I do this occasionally, and I just love the machines and love the ability to do my own stuff. Yeah, I'm feeling good with all this. Oops, right now. Oh, this is gonna be freaking sweet. All right. I guess thanks for watching Doozer Shop. And I'm just on cloud 9 that I was able to take my 1957 International block, or maybe it's a 58, I forget, and you know, put a modern seal in it that's, you know, more likely to not leak. All right, talk too much. Thanks for watching. Until next time, this is Doozer Shop.